and this is the help video to help you do the simultaneous equations exercise online. It's not intended to teach you how to do simultaneous equations for the very first time, but it's assuming you've learnt it at school and you just want a refresher. So here we start with level 1, and this is typically what a pair of simultaneous equations would look like at level 1. This is how you solve them. Very important first step is to label the two equations, either 1 and 2, or in this case A and B, so that we can talk about them. And we can see that each equation contains two letters, A and B. And if we just had one of the equations, we wouldn't be able to solve it because there would be lots and lots of different values for A and B that would make the equation true. But because we've got two equations that are both true simultaneously at the same time, we can actually solve it. So the technique for this is, let's see if we can get rid of one of the letters first and then just find out what the other letter is. This is called elimination, and it's just one of the methods of solving simultaneous equations. So the first thing I'm going to do is notice that both equations have got two b's in them. So if I subtract equation B from equation A, what I'll be left with is, on the left side, I'll have 3A take away 2. A is A. Then 2B take away 2B is nothing. And then on the right side of the equation, I've got 12 take away 10 is 2. So just by doing that one thing, I've found out that A is 2. Now what I'm going to do is I'm going to substitute this value of A in the first equation. So I'll write out the first equation, but instead of the small letter A, I'm going to write the number 2. So 3 times 2 is 6. So the first term is 6. I don't know what B is yet, so I'm going to write 2B, and that's equal to 12. Now I've got a simple linear equation that I can solve. I'll take away 6 from both sides, and then I'll divide both sides by 2. So B equals 3. Here are my two answers. First one is A equals 2. And the second one is B equals 3. Those are the two values that make those two equations true. Okay, let's have another example. Right, we've got x's and y's in two equations, and we have to find out what their values are that will simultaneously make those two equations true. So as before, the first step is giving them a name each. I'm going to call the top one A and the second one B. Now this time, even though we've got 3y in both equations, here we have plus 3y and here we have minus 3y. So what I'm going to do this time is add the two equations together, because if I add together 3y and negative 3y, I'll get 0. So adding the two equations will eliminate one of the variables. So what's 7x added on to negative 5x? Well, that's like 7x take away 5x. So that's 2x. So when I add the equations, on the left I will get 2x. These will cancel each other out. And then again, adding the right hand side gives me a 6. So x is equal to 3. So there's the first solution. X is equal to 3. Now what I'm going to do is substitute that into the first equation, A. So now I know x is 3. I can write out equation A again, but replacing the x with a 3. So 5 times 3 is 15, but it's negative, so negative 15. Add 3y is equal to 3. I'm going to add 15 to both sides to get 3y equals 18, and then divide both sides by 3, so y is equal to 6. So there are my two solutions. X is 3 and y is 6. Now to check these, I could put those values back into the original equations and make sure that they're true. So minus 5x would be minus 15, 3y would be 18, so minus 15 added onto 18, yes, that does give 3. Checking the second equation, 7 times 3 is 21, take away 3 6s are 18, so 21 take away 18 does give me 3. Yes, I'm confident that those two answers are correct. Now let's move on to level 2. So here's an equation that you might get in level 2. So, as with all of these, the first step is to label them A and B. Okay, so I can see that we don't have a case where one of the letters has there are the same number of them in both equations. We have 2d here and 3d there, and we have 2c there and 1c there, and we want to try and eliminate one of them. So what we're going to do first is we're going to take equation B and multiply it by 2. So now I can write down the whole of equation B but multiplied by 2. So we have 2c instead of just 1c, we have 6d, and now that's equal to 48. I've doubled both sides of the equation, so the equation still balances, but now we can see that we have 2c here and 2c there. I think I'm going to label this equation C. So now we'll notice that we have the same number of c's in equation A and equation C. So what I'm going to do is I'm going to subtract equation A from equation C. 2c take away 2c is nothing. 6d take away 2d is 4d. And 48 take away 24 is 24. Now I'm going to divide both sides by 4, and I'm going to get d equals 6. So I found one of the letters in this pair of simultaneous equations. So now I'm going to substitute that into equation A. So that value of 6 for D, I'm going to put in equation A. So that gives me 2c, and then 2 6's are 12, and that's equal to 24. Now I'm going to subtract 12 from both sides. Now I'm going to divide both sides by 2. And I've got the second answer. So here are the two values that will satisfy those two equations simultaneously. And remember, we can always check by putting those two values into the equations and seeing if they balance, seeing if they make sense. Okay, well, second example for level 2 looks a bit like this. 12x plus 3y equals 60, and 6x subtract 6y is 0. So you're getting the routine now. We're going to label them A and B so that we can talk about them. And I can see that we don't have the same number of either of the variables. So what I'm going to do is I think I'll multiply the first equation by 2, and then I'll have 6y there, and that will, I can use these two equations now to eliminate the y's. Alternatively, I could take equation B and double every term, because then the number of x's would be the same. So it doesn't really matter what you do. I'm going to take the first idea and take equation A and multiply it by 2. So the first equation multiplied by 2 is going to give me 24x plus 6y is equal to 120. Now I can see that I have the same number of y's in these two equations. I'm going to call this equation C. So now I can talk about it. And because we've got plus 6y here and minus 6y there, if I add these two equations together, the y's will disappear. So 24x plus 6x is 30x. Plus 6y added on to minus 6y is 0. And then 120 add on 0 is still 120. And I forgot to write down what I'm doing. I'm taking equation C and I'm adding it onto equation B. So I just write down there what I'm doing so that you can see. Then I'll divide both sides by 30. So x is equal to 4. So for this example, I've got x is 4 as one of my answers. Now I can substitute that into either of the original equations. I think this time I'll go for B, because the numbers are a little lower, I guess. So putting the value of x into equation B, x is 4, so 6 4s are 24. Take away 6y equals 0. What I'll do now is I'll subtract 24 from both sides. Now I'll divide both sides by negative 6. So I've got two answers here. X is 4, but also y is 4. They are the two values that satisfy those two equations simultaneously. Now we're on level 3. Okay, getting a little bit more tricky now, because I can't think of anything that I could multiply equation A or equation B by so that one of the letters is the same as the other equation. I think I'm going to have to do a bit of both. So let's see, let's get rid of the f's here. So what I'll do is I'll multiply this equation by 2 to get 12f, and multiply this equation by 3 so that I've also got 12f, and then I can subtract the equations to eliminate the letter f. So I'll write down what I'm doing. I'm going to take equation A and I'm going to multiply it by 2 in order to get the lowest common multiple of those two numbers. So equation A multiplied by 2 will give me 8e plus 12f equals 92. And I'm going to call that equation C. And now I'm going to take equation B and I'm going to multiply that by 3. So that will give me 15e plus 12f is equal to, and I've got to work out now what's 3 times 47. Well, 3 times 40 is 120. 3 times 7 is 21. Add them together, 141. I'll call that equation D. Now I've got two equations which both contain 12f. So if I subtract one equation from the other, I will eliminate the f's. Now which way around shall I do it? I can see I have the bigger numbers here, so I think I'm going to take equation D and I'm going to subtract equation C. 15e take away 8e is 7e. 141 take away 92 is 49. I'll divide both sides by 7, and I've got e equals 7. When you've got one of the variables, you can substitute into either of the original equations. So substitute into, well, there's not much difference. They're both very similar. I usually choose the one with the smallest numbers involved. So I'm going to choose A in this case. So I'm putting the value of e is 7 into this equation A. So 4 7s are 28. I don't know what f is yet, so I just have to write down the rest of the equation like this. Now, I can subtract 28 from both sides, so I get 6f equals 18. So f is equal to 3. So there are my two answers. E is 7 and f is 3. And remember to check, you could substitute those values into the original equations to check they balance. Okay, one more example for level 3, and it looks like this. Okay, you're probably getting to the routine now. The very first thing we do is we label the equations A and B. Right, let's see. Looking at the letters, we've got 9x and 10x negatives, and we've got 5 and 3. I think I'll go for the 5 and 3 and try and get the y's in a form that I can eliminate. So the lowest common multiple of 5 and 3 is 15. So I'll multiply this equation by 3 and this equation by 5. Here we go. A multiplied by 3 gives me minus 27x plus 15y equals 15. And I'll call that equation C. Then I'll take equation B and I'll multiply that by 5. So I have minus 50x plus 15y is equal to minus 100. And I'll call this equation D. So now I've got the same number of y's in both equations, both with the same sign. So if I subtract one equation from the other, I will get one equation that doesn't contain any y's. So I think I'll take the bigger number and then I'll subtract the smaller numbers. So I'll take equation C and I'll subtract equation D. So let's see how that goes. Minus 27 subtract minus 50. That's like minus 27 add 50. And that's like 50 take away 27, which must be 23x. Of course, when I take this one away from this one, I get 0. So on the right side, doing C take away D, 15 take away negative 100. That's like 15 add 100. So that's 115. So now divide both sides by 23. I'm having a guess that there are 5 23s in 115. So I'll multiply that by 5. Yes, I get 115. So that is our first answer. X is 5. So if you know the routine now, we'll substitute into which equation looks the simplest to work out. They're both much of a muchness really, so I'll go for A. So I'm going to substitute the value of x is 5 into equation A. So let's bring that up here. So x is 5 into equation A, so that will give me minus 45 plus 5y is equal to 5. Now I'll add 45 to both sides, so 5y is equal to 50. Divide both sides by 5, y is equal to 10. So the two solutions to these simultaneous equations are 5 and 10. We're now on level 4, where I can see that the equations are perhaps mixed up a little bit. But nevertheless, we'll go through our routine. I'll call the two equations A and B. And then, well, B isn't in the format that we've had in the previous examples. So I think the first thing I'm going to do is I'm just going to rearrange equation B so that I'll subtract g from both sides. So it's minus g and then the plus the 2h, and then that's equal to negative 5. And I'm going to call that equation C, even though it's the same as equation B, just rearranged slightly. But now these two equations, A and C, have got the letters in the same order and they've got the numbers on the right there. And I can see that we have a plus g there and a minus g there. So if I add these two equations together, the g's will disappear because g added on to minus g gives you nothing. So minus h added on to 2h gives you h. And then 8 added on to negative 5 will give you 3. Wow, already I found one of the letters. That was quick. So now the routine is we'll substitute that into equation A. So now we know h is 3. We have g minus 3 is equal to 8. Add 3 to both sides. G is equal to 11. So as long as you can rearrange an equation, then it's quite simple. Plain sailing after that. Okay, here's our second example. 5x equals negative 3y and 2y plus 3x equals 4. Right, well, the first thing I'll do is rearrange both of them, I think, so they're in the form I'm used to seeing. I'll add 3y to both sides, and then I'll have that equation called C. And then for this equation, I think I'll put the x's and the y's in alphabetical order. So 3x plus 2y is equal to 4, and I'll call this equation D. Now, I can see that the coefficients of neither of the variables are the same, but I can see here that the 3 and the 2, they have a lowest common multiple of 6. So I'm going to multiply this one by 2 and this one by 3. So equation C multiplied by 2 gives 10x plus 6y is equal to 0. And then equation D multiplied by 3 will give me 9x plus 6y is equal to 12. And we'll call these equations E and F. Right, now we have 6y in both of these, so I'm going to subtract equation F from equation E. So I'm going to take equation E and subtract F. So 10x take away 9x is x, 6y take away 6y is nothing, and 0 take away 12 is negative 12. So one of the answers is negative 12. I'm now going to substitute that into equation A, which, if you remember, was 5x equals minus 3y. So now I know that x is negative 12. 5 times negative 12 is negative 60, and that's equal to negative 3y. So if I divide both sides by negative 3, I'll have y is equal to 20. So the two answers are x is negative 12 and y is 20. Which brings us to level 5, where we have some problems that don't look like simultaneous equations at all. In fact, there aren't even any letters mentioned in the problems. So I think we have to make up some letters of our own. So here we go. Okay, so I've invented the letters X and Y to stand for the two numbers. And now I can write down what's been said in the question in terms of algebra. It says the two numbers have a sum of 17. So X, the smaller number, plus Y, the other number, must equal 17. And it says the smaller number subtracted from the larger number equals 9. So we have Y subtract X is equal to 9. And lo and behold, we have two equations, two simultaneous equations, which, as you know, can be solved by first labeling them A and B. Right, well, the letters aren't the same way around, but I can see actually that if I add these two equations together, if I add the X and the negative X, that will be eliminated, leaving me with just Y's. So I'm going to add the two equations together. So when I add the X to the negative X, I get 0, Y to Y, I get 2Y. So 2Y, then I have to add the right-hand sides. So that's going to give me 26. So Y is equal to, dividing both sides by 2, 13. Already I've found out one of the numbers. Right, let's substitute into equation A. So we know that Y is 13, so X plus 13 is equal to 17. Subtract 13 from both sides, X is equal to 4. Now, we shouldn't really leave our answers like this, because the question didn't ask us to find X and Y, it asked us to find two numbers. So I suppose in terms of the wording of the question, the answer would look like this. There we go. Right, let's have a look at another example from level 5, and it looks a bit like this. Again, a problem written in words. It's about the perimeter of a rectangle. Right, so I'm going to draw a sketch, a very rough sketch of a rectangle here, and it says its length is 11 centimeters longer than its width. But I don't know what the length and the width are, and I haven't got any letters, so I'm going to make up some letters. So I think I'll have W for the width, and I think I'll have L for the length. And now I can write down what's said in the question in terms of the letter. It says the perimeter of a rectangle is 118. So the perimeter is the distance all the way around. So that looks like 2 W's and 2 L's. So 2W plus 2L is equal to 118. And then it says that its length is 11 centimeters longer than its width. Right, so if I have its width and I add on 11, I will get the answer L, because the length is 11 centimeters more than the width. It looks very much as though we have two simultaneous equations with two unknowns. So what I'm going to do is write the second one down with the letters in the same order as the first one. So I'm going to keep the W on the left, but I'm going to subtract L from both sides, and I'm going to take away 11 from both sides, and that's giving me equation C. So now equation C and A are things are sort of lined up, and now I can see that maybe in order to get rid of one of the letters I need to double this equation. So I'm going to double equation C, so C times 2, and that will give me 2W minus 2L is equal to minus 22, and we'll call this equation D. Now we have got one of the letters, plus 2 of them there and minus 2 of them there. So if I add these two equations, A and D, it will eliminate the L's. So add the two equations. 2w plus 2w is 4w. The l's disappear. And then add 118, take away 22. Goodness, what is that? I think it is 96. So w is equal to, divide both sides by 4, that will give me 24. So it looks like the width of this rectangle is 24. Now I need to find the length, so I'm going to substitute. So add these two together, and I've got L is equal to 35. But remember, we shouldn't leave our answer in terms of letters that we've made up. So I'm going to finish off by writing down that the we've now reached level 6, and we have equations with fractions in them. So we haven't been doing these before, so I think the first thing we'll do is we'll take that first equation and we'll multiply throughout by 3, and that should get rid of the fraction involved. So we have 15m plus n is equal to 138, and I'll call that equation C. And to get rid of the fractions in the second equation, we'll multiply through by 2. So that will give me m plus 6n is equal to 116, and I'll call that equation D. And then you can go on to solve that as you have done in previous levels. So m is 8 and n is 18. And finally we get to level 7, where we have one quadratic equation as our pair of equations. So let's not be put off by that. Let's do what we've done in all the previous levels. We'll label these A and B, and then I think I'll rearrange B so it's in the same order as the terms in A. So I'm going to have my x squared. I'll subtract y from both sides and have minus y next, and then I'll add 94 to both sides and have the 94 over here, and I'll call this equation C. So now we have a minus y and a minus y in both equations A and C. So I'm going to take equation C and subtract equation A. So x squared take away x, is x squared minus x. The minus y take away the minus y is nothing. 94 take away the 4 is equal to 90. Now this equation that I've got here isn't a linear equation anymore, it's a quadratic equation. And one way of solving quadratic equations is by first getting all the terms over to the left side like that, and then factorizing it. And it should be a nice easy factorization because we have only got one x squared there. So we're looking for two numbers that multiply together to give negative 90 and add together to give negative 1. So I think those two terms are negative 10 and plus 9. Negative 10 times plus 9 gives negative 90. And then we'll have a minus 10x and a plus 9x. That will give us the minus x there. So that means x is equal to 10 and x is equal to 9. So we have two values for x this time instead of just one. Right, we can substitute these back into the first equation, equation A. So let's see, if I put x is 10 here, I'll have 10 minus y equals 4. So y must be 6. So y is equal to 6, and that's the value of y that goes with that value of x. And, whoops, I missed the minus sign off there. Let's put minus 9 into that equation. So if x is minus 9, we have minus 9 minus y equals 4. Add 9 to both sides. So that gives minus y is equal to 13. So y is equal to negative 13. So that's the value of y that goes with that value of x. And those are all the answers to that final pair of simultaneous equations. Okay, now it's a chance for you to have a go at the online exercise. Don't forget to earn a trophy at each level. If you get really stuck, see your teacher. And there are lots more activities on Transom for you to enjoy and to help you improve your mathematics. Take care. Bye-bye.
You can find Transom Mathematics at www.transom.org, where you're welcome to use all of the activities absolutely free. Or jump in with both feet and become a Transom subscriber.